In this video we are going to see the Tricalc 22 model of a structural calculation for light steel frames. To define this type of a structure, it can be useful to start with a simple joints and members geometry. We are going to start by selecting a vertical plane and displaying the work plane. Inside the geometry menu, the function light frames define frame enables to define rectangular panels, lattice beams, wide flange beams and stairs. We are going to choose the rectangular panel. In the first box, we can define the length of the panel, typing it or clicking it in this button and selecting 2 points of the structure. In this case, the distance between these 2 points is 6 meters. We can indicate the program to divide those 6 meters in 6 equal parts, or like me, choose 12 equal parts. But we can also put in a specific separation, for example every 50 centimeters, and the rest leave it in the center, to the left, to the right, or to both sides. In this case, for example, all the spans are 50 centimeters, but if I put, for example, 55, you can see that in the left side I have a little less, and in the right side I also have a little less. But we are going to leave it with 12 equal parts. It would also be possible to define each of these sections numerically or writing its value with this button. We select 2 points in the model. We will leave it with 12 equal parts of equal length. With the heights, it is the same. We can define its value or click 2 points. For example, from here to here. And we ask it to divide it in 3 equal parts. The next page of the assistance allows me to choose if we want each of these vertical elements to be single or double. Here we have a double section. Doing double click, you can change it directly, and the direction can be increasing or decreasing, which indicates that the sole of the section is situated on the right or on the left. In the next page of the assistant, we can indicate if we will have diagonals or not in each part. For example, I am going to select all the spans, and with this icon I can indicate that I want diagonals. If I put 2 diagonals, for example, the geometry would be this one. I am going to ask for only 1 diagonal in each part. I am going to put the right side spans with the opposite direction. It is also possible to select with this icon any span to change its direction, but we are going to leave it how it was. If you want to eliminate any element from the structure, this icon allows you to eliminate horizontal elements. This one allows you to eliminate vertical elements, and this one allows you to eliminate diagonals. In this way, it is very easy to open holes in the panel, but we are going to leave it how it was, in this case with no holes. I select all the spans and ask to do the diagonals. I also want all the vertical members to exist with this icon and all the horizontal members as well. In the next page of the assistant, we are going to select the type of section we want for the members. You can select all sections of the same type or differentiate horizontal and vertical members or diagonals. The button search enables to access to the database of the sections that is expandable and can be used for this type of a structure shape section, like shape C, for the upper and lower horizontal sections. We are going to choose, for example, these sections of 1.5 mm thickness, and we are going to use the same section for all the members. Here we can choose if we want anchor bolts for the panels to the base, for example every 40 centimeters. In the last page of the assistant, we are going to place this panel inside the model. So the insertion points that we can choose is the left point, the central point, and the right point. And we place it in our model, in this case in a vertical plane. Checking this point and this point, that indicates the direction. We finish with the exit button and we have our panel created. It is located from the plane we had already defined, facing the interior of the building. In the same way, we create the rest of the rectangular panels of this plane. We are next going to create horizontal rectangular planes. We go to a horizontal plane, for example, that goes through this point, and we get closer to this area. We execute the same function as before, define panel, rectangular panel, but the length is the same, so we don't change anything in the first page of the assistant. But in this case, the height, we are going to define it from this point to this point. We divide the height by 5 equal parts, and we indicate that all of them are 60 centimeters, except of the last one. For that, we click on this icon. In the next page of the assistant, we don't make any changes. In the next one, we indicate we don't want any diagonals. We deactivate them with this icon. We are going to eliminate as well some horizontal members and some vertical members to do a whole. We eliminate these horizontal members, and with this icon, we eliminate these vertical members. In the last page of the assistant, we locate it in the model. We are going to choose as point of insertion this one. We click the button and select the point. We click to insert it in a horizontal or inclined plane, and we select 3 points. The first one here, the second one here to define the baseline, and the third one enables to incline the plane or put it horizontally. We select in this case this point over here to get it set. At last we click exit, so we have the horizontal plane created in the same way we created the other 2 horizontal rectangular panels, but without holes. We are going to activate again the vertical plane to draw the lattice beam of this area. We activate it in the same function as before. We get closer to this area and we execute the function light still frames define panels. In this case, we select lattice beam and we accept. This typology enables to do single or double beams that can be rectangular or triangular. In this case, we are going to make it double and symmetric. In the next page of the assistant, we define the principal dimensions, the maximum height, minimum height, the length of one of the parts, and define the number of spans of one of them. They can be the same or not. In this case, I'm going to divide it in 6 parts. In the next page, we can select as well if we want simple or double sections in an increasing or decreasing direction. In the next page of the assistant, we can select if we have or not diagonals. We could indicate, for example, that in each span there are 2 diagonals. And we also could eliminate the vertical members. The first one, we are going to keep it, but we are going to leave it as it was in the beginning, with all the vertical members and just 1 diagonal. The next page enables us to select the section we are going to use. They can be the same or different from the chords, mullions, and inclined paths. And we located this lattice beam inside the model. We select the point we are going to change it with the one on the other side, and we insert it in a vertical plane. From here to here. We end it with the button Exit. In the middle area, we are going to do a rectangular beam with similar functions to the upper one. For that, we go to Light Steel Panels, Define Panel, Lattice or Rectangular Beam, and Accept. In this page, we don't change anything. And here, we select Rectangular. In the next page, we are going to define the height. We click on this icon and we select 2 points, from here to here. We are also going to select the total length, which is 6 meters, and the number of equal spans, that we are going to make it 12. In this page of the assistant, we don't change anything. We keep going, and in this page we indicate that we want 2 diagonals in each span with this icon. 2 diagonals, and accept. And we change the direction with this icon. At last, in the final page of the assistant, we select the insertion point. That is going to be the same as before. Insert in vertical plane, and we locate it from here to here. If we indicate the direction is enough. And we finish with the exit button. We are going to copy some of these panels and locate them in other frames. I go to the function copy and I go to the panel 1, 2, 3, 4, and 5, and I click escape. and I select as insertion point this central point. Now I execute the paste function. I select this knot, another time paste or Ctrl V, and I select this knot. This way I am going to copy again the same panels 1, 2, 3, 4 and 5, and I click escape. And in this case the point of insertion I am going to select is this one on the left. If we get closer, you can see it's this one over here, and I'm going to paste it with the function paste in this frame over here. This way the lines I had defined correspond to the exterior side of the panel. In a natural way we define as well these 6 rectangular panels. Also, the inclined panels of the roof are defined the same way we defined the horizontal planes. We zoom in and we execute the function define panel, rectangular panel, and accept. Here we define its dimension, and in the last page of the assistant we choose to insert in a horizontal or inclined plane, and we select 3 points. First point, here second point, and the third point to define the inclination of the panel, here. Once the panel is defined, we click Exit. With the same functions we defined the rest of the panels of our model. In the list of work planes we can activate each of the vertical or inclined planes that form it. Here we have frame 3, frame 5, frame 6, and in the other direction frame A, frame B, and frame C. In the 3D View Filter window, it is also possible to deactivate some panels particularly and displaying them in the work plane. If we wanted to modify any of them, it is possible with the function Modify Panels, selecting it, and we access again to the assistant to change any data about them. It is also possible to move them with the option Move Frame. We select the frame we want to move, an initial point, and a final point. The function Introduce Service Holes allows you to define some lines from which they are going through different installations, such as plumbing or electricity. These lines will be taken in consideration to make holes in different elements and can be eliminated with the function Eliminate Service Holes. The function Create a Tricalc Model creates the calculation model, and once you have calculated it, it is possible to deactivate the drawing of the panels. In this way are created the footing, the joints, and the members that are going to be used in the calculation through the usual menu loads. We can introduce, for example, any member loads, gravity loads, wind loads, or earthquake loads. After that we select Draw Panels to see all the loads in the drawing. When the calculation is done, we can get the usual results. For example, some of them can be graphs. This is the displacement graph of the structure. This one is the steel stress graph. And this is the earthquake animation that shows the vibration modes. This is generated in a video file in AVI format.